the electronic valve engine. More specifically, a variable flex field valve train.
There are two primary objectives of this concept. Eliminate much of the weight, expense, and losses that burden a conventional valve train. Provide the engine designer with essentially infinitely variable valve timing and simultaneous control over valve lift. This moving magnet flux field reduces drivetrain mass by 90% and cuts parasitic losses by 70% as compared to a cam-driven valve train.
Electromagnetically operated valves are not a new idea. General Motors, Cummins, BMW, and International are just a few engine manufacturers that are or have been active in this field.
Experimental designs to date have encountered problems with packaging, high electrical power consumption, inadequate response times limiting RPMs, and failures to meet valve lift control objectives.
This production 3.2-liter naturally aspirated 6-cylinder diesel has been converted to an EVE valve train. Watch the digital tachometer in the lower right as the engine is stepped up to its horsepower peak at 4,000 RPM. Let's take a closer look at the valves in operation. And from the other side, ignore the terminal block, a laboratory convenience in this experimental setup.
A continuous amp readout records the total current draw for all 12 valves, which in this 12-volt system amounts to around 1 horsepower. Considering some conventional valve trains consume as much as 8 horsepower, the reduced parasitic loss is apparent. The EVE brake valve to follow its individual timing and lift algorithm as dictated by the electronic controller. An indicator of the large reduction in parasitic losses is engine coast at shutdown. Let's shut it down once again so you can see how the engine coasts to a stop. That coast means reduced losses.
This display board shows what parts are no longer needed in this test engine. The cam and cam pulleys are across the bottom to give you a sense of scale. That's a lot of iron and lots of expense with no means of tailoring timing and lift to optimize performance and emissions. A few more expensive parts would have been added to the board if we had started with a variable valve timing engine.
Today, many engines are constrained to a conventional valve lift timing curve. Some engine manufacturers shift the timing one way or another. EVE provides the engine designer the opportunity to optimize valve timing and lift to help meet all his objectives. He can not only shift the curve timing, but he can tailor its shape. And each valve can be controlled independently of the others.
In this little demonstration, we've slowed the valve to better show the variable lift flexibility.
EVE presents possibilities. Among them are deactivation of cylinders, increased engine braking, variations in valve timing and lift cylinder by cylinder to compensate for manifold flow variations, among many other opportunities. The Eve engine replaces this board of parts with this and demonstrates what is possible in this diesel engine, a significant contributor to a horsepower increase from 88 horsepower to 120. Could applying Eve capabilities to your engines help in achieving your goals?